Hello students, today we will start very fundamental topics of physics, which is unit and measurement, and it contains the physical quantity, measurement, unit system, classification of physical quantity, advantage of SI system, SI prefix and symbol used to denote the power of 10. One thing is that physics is nothing but a quantitative science, for which we have to gather the knowledge of the physical quantity. What is physical quantity? Physical quantity is that quantity can be measured and expressed with a number and unit, and also the various physical happening can be explained in the form of law. Okay, so it can be expressed in terms of number and unit. Suppose you are sitting in a table. What is the length? 5 meter, 5 centimeter, 5 kilometer. What is the actual length? Okay, that means here any physical quantity can be expressed in terms of one numerical value and another is the unit. Okay, this is the unit. Now you have to measure, or physical quantity it can be measured. Now we have to measure with terms of proper unit. Suppose you are measuring length, obviously unit will be meter, if not kg. Okay, so the measurement is the process which the physical quantity is compared with standard amount of unit. Where suppose mass of a body is 40 kg. 40 kg. This is the standard. Kg is the standard, and mass is 40 times of this standard. Okay. Now here this number, what are the n and u, what we are taking, that is always constant. Okay. So n is proportional to 1 by u. That means molar unit magnitude will be larger. Suppose here this is kg. If you go to the gram, then it will be 40 and 3. So it will be, if it is smaller, then it will be larger. Okay. So this is the measurement. And unit system, here you see we are taking 4 system: CGS, FPS, MKS. Here all base unit fundamental quantity is taken: length, mass, time. For which in CGS system length is centimeter, mass is gram, time is second. Similarly for FPS system, length foot, mass pound, and time is second. It is British system. MKS system, lateral MKS length is meter, kilogram, second. And SI system we will discuss later. Okay. Now we move to the classification of physical quantity. Physical quantity can be classified by two ways. One is the directional properties and is the dependence properties. Directional properties, it is the scalar type, vector type. Detail of the scalar and vector we will discuss in another chapter, motion in plane. Here I am giving only the fundamental things. Scalar quantities only have the magnitude, but vector quantities have both magnitude and direction. Mass is a scalar quantity and velocity, displacement, force is the vector quantity, is the both magnitude and direction. According to the dependency, it can be divided as the fundamental quantities and derived quantities. Fundamental quantities are those quantities which are the independent and cannot defined in the other terms, the fundamental quantity. And derived quantities are dependent on the fundamental quantity. Now here in SI system, there is a 7 fundamental quantities. The 7 fundamental quantities are length, which unit is meter, it will be denoted as small m. Mass, unit is kg, kilogram, and unit is kg. Time, unit second, the SI system will be the S. Electric current, unit is ampere, written A. Temperature, unit is taken Kelvin, written as K. Amount of substance, mole, it is written as small, only mole, MOL. And luminous intensity, the candela, CD. All these 7 quantities the fundamental quantity in SI system, and units of these fundamental quantities is the fundamental units. And derived quantities are those quantities which derived with the help of the fundamental quantity. Suppose we are considering speed equal to length by time. So obviously what will be unit equal to length unit is meter, time unit is second. So this is the speed unit is also meter per second. And the supplementary unit is there. Here we are considering two things. One is the plane angle and the solid angle. Plane angle, we know that when two straight line or rays on a certain point, then angle will be different. Here this angle, we know that angle equal to arc by radius, S by R. So unit is radian. Solid angle, here this is the nothing but a cone, this is the area. So solid angle equal to surface area by R square, that equal to F by R square, that is the steradian. Unit is the steradian. Now what are the advantage of the SI system? Here the coherent system of units. Derived unit, simply you take the multiplication and division of the fundamental unit. No other things are there. Only multiplication and division of the fundamental unit. Suppose the unit of the acceleration equal to velocity by time. Velocity equal to also length by time. So here simple we are getting meter per second square. Okay. So and it is also a resonance system. You see, for energy only one unit, joule. Whatever the thermal energy, mechanical energy, whatever the energy, unit will be joule. In metric system, here it is the multiple of 10. If we change from one to another system, metric system, multiple of 10. And here only absolute system unit is there, and it is internationally accepted. Now we move to some SI prefix which is very much required for the numerical. When you do the numerical, then it is very much required. Now here you see, first we will start 10, deca, it will represent DA, hecto, 10 to the power 2, hecto, only H, 10 to the 3, it is kilo, only K, 10 to the 6, mega, M, 10 to the 9, giga, G, 10 to the power 12, tera, T, 10 to the 15, peta, P, 10 to the 18, exa, E, 10 to the 21, zeta, Z, 10 to the 24, iota, Y. Similarly, 10 to the minus 1, deci, small d, 10 to the minus 2, centi, small c, 10 to the minus 3, milli, small m, 10 to the minus 6, micro, mu, 10 to the minus 9, nano, small n, 10 to the minus 12, pico, small p, 10 to the minus 15, femto, small f, 10 to the minus 18, auto, small a, 10 to the minus 21, jepto, small z, 10 to the minus 24, ioto, small y. Okay, thank you.